Let's talk about the physics you use every single day, probably without even thinking about it. It all happens inside one of the most common and, honestly, most mysterious boxes in our homes, the microwave oven.
I mean, really think about it for a second. It's kind of a bizarre process. There's no fire, there's no glowing red hot coil like in a toaster. You just put cold leftovers in a box, and 60 seconds later, they're steaming hot. What is actually going on in there?
And of course, we've all heard the stories. People always ask those two big questions. Does it really cook from the inside out? And maybe more importantly, with all this invisible energy bouncing around, is it actually safe? Well, we're going to get into all of it. To get how a microwave works, you first have to understand what it's working with. And here's the secret. It's not heat in the way you might think. It's a form of pure invisible energy. The name microwave literally tells you what it is. We're talking about a specific kind of electromagnetic wave. You know, they're in the same big family as the radio waves bringing music to your car or the visible light that's letting you see this right now. The only real difference between them is their wavelength. Now, here's a key number. The frequency most home microwaves use is 2.45 gigahertz. And that is not a random number. It was picked for a very, very specific reason, which we'll get to in just a sec. But first, you have to appreciate just how massive that number is. 2.45 gigahertz means the electric field inside that oven is flipping back and forth 2.5 billion times every single second. That's a staggering amount of energy. So why that specific frequency? Why 2.45 gigahertz? Well, it's because that frequency is perfectly tuned to mess with the one ingredient found in almost every food you eat: water. You see, a water molecule is what scientists call a dipole, but a much easier way to think about it is like a microscopic magnet. It's got a positive end and a negative end. This one simple fact is the entire reason microwave cooking even works. Okay, remember that super fast flipping electric field? Well, when that field hits your food, it grabs onto all those tiny water magnets and tries to force them to line up with it. But since the field is flipping billions of times a second, the poor little water molecules get thrown into this frantic, violent, high-speed dance. And this is where the magic really happens. All of that chaos on a molecular level is what we feel as heat. So how does all that spinning and dancing actually make your food warm? So here's the thing to remember. The microwaves themselves aren't hot. They're just the energy source that gets the water molecules spinning like crazy. As they tumble and spin, they're constantly bumping into and rubbing against all their neighbors. This creates an incredible amount of friction. And what does friction create? Heat. This is the perfect way to picture it. It is the exact same principle as rubbing your hands together on a cold day to warm them up. The microwave just makes that happen on a tiny molecular scale, generating intense heat from the inside of the food. But, as we all know, this process isn't always perfect. We've all done it. You pull like a plate of lasagna and one spot is molten lava while the center is still ice cold. So, why does that happen?
Well, the reason is that those microwaves don't just fill the box evenly. They bounce off the metal walls, and they interfere with each other, creating a pattern. It's a pattern of standing waves, with peaks that have a ton of energy and valleys that have almost none at all. A thermal camera shows this perfectly. Those bright yellow spots are the hot spots. That's where the peaks of the waves are, cooking food like crazy. And the dark purple areas? Those are the cold spots. If you didn't have a way to deal with this, your food would be both burnt and frozen at the same time. And that brings us to the really simple but totally brilliant solution: the turntable. By rotating the food, it makes sure every single part of your meal gets a turn passing through both the hot spots and the cold spots. That's how it gets everything cooked much more evenly. Okay, so we've got these really powerful invisible waves bouncing around inside a metal box, which of course brings us back to that other big question. Is this whole thing safe? The answer is a definite yes, and it's thanks to a classic physics concept. Your microwave oven is basically a Faraday cage. That's just a scientific way of saying it's a box made of metal, which is great at conducting electricity. And that design traps electromagnetic waves and stops them from getting out. There are a few key things that make it work. First, those metal walls reflect the waves back into the oven. Second, you see that black grid on the door? The holes in that grid are way, way smaller than the microwaves themselves, so the waves can't escape. And third, there are multiple safety switches that instantly kill the power the moment you open the door. And let's just bust a huge myth while we're on the subject. Microwave food is not nuked.
It's not chemically altered in some scary way. The energy in these microwaves is thousands of times too low to actually break the chemical bonds in your food. The only thing it's doing is heating it through friction. It's just a different way to make things hot. So where do these powerful waves actually come from? Let's take a look at the engine that drives this whole process.
Deep inside your microwave oven, there's a device called a magnetron. It's a pretty amazing piece of tech that takes the regular electricity from your wall outlet and, using some powerful magnets, turns it into that precise 2.45 gigahertz beam of microwaves that does all the cooking.
So the next time you go to heat up your coffee, just remember what's really going on in there. It's not some kind of magic. It's this incredible, perfectly orchestrated dance between electromagnetic fields and water molecules, just some powerful, everyday physics working for you in your kitchen. So now that you know it's not magic, it's physics, it kind of makes you wonder, what other piece of everyday technology should we break down next? Let us know.